Alrighty, welcome to a new unit on quadratic functions. We're going to start off by just looking at the three different forms a quadratic can be written in, and then from there we'll go into the different properties of each one and how to convert between them. So in the beginning, just to get an idea, in the last chapter you learned about what a parabola is and how to graph it and slide it around, but we didn't really talk about the properties of the different resulting equations that we got. We just talked about whether they were slid left or right or up or down, how much they were stretched or shrunk by, and whether they were flipped over an axis. But now we're going to really dive into just the parabola and quadratic in full detail and study it similar to how we studied a linear equation with different forms to write it in and what each one tells you and how to graph them, etc. So with linear equations we had three different ways to write it. There was only one line, but it could be represented in three different ways. The same is going to be true of a parabola. There's going to be three different equations you can write, but they all represent the same graphical parabola and the same input-output relationship between the variables. So the first form is called vertex form, and vertex form is similar to what we've seen a lot in chapter 8, because when you slide a parabola around, the vertex is what changes. So your normal parabola, if the vertex was at 0, 0, and you haven't done anything at all to it, you would have y equals x squared. But we learned that if you slide left and right, h and k, and up and down h and k, you can get a new parabola. And so the vertex form is y minus k equals a, parentheses, x minus h squared. So you can see that x became x minus h, which means that the vertex has moved to the right, because of the opposite sign, to the right a distance h, and the parabola has moved, or the vertex has moved. Y minus k means we moved up, so we moved up a distance k. So the amount that we moved to the right and up is the new location of the vertex. So in vertex form, what you have is h comma k as your vertex, and then you've got a stretch factor, which is the a value. So if there's an a, say a is 2, we've been stretched by a factor of 2. Sorry. This could also be a shrink factor. If a is less than 1, like say it's a 1/2 in front or a 0.25 or something, then it's been shrunk. But in general, this form should look very familiar because you've seen it over and over in the last chapter. Okay. The next form is called standard form. Just like standard form of a line, this one is not necessarily the most useful in terms of knowing how to draw a graph, but it is useful for many other aspects of parabolas. And so standard form is y equals ax squared plus bx plus c. And so it's written as a polynomial. There's no parentheses, it's just the sum of three terms. A or b or c are all numbers. So a is the stretch factor. Again, we used a again because it's representing the same thing, but b and c are different than h and k because, well, they stand for different stuff. So a is still the stretch factor. C, it turns out, is, we'll try to think about it. What does c stand for? If this was a linear equation, this term would be gone, and you just have bx plus c. We used to call that mx plus b, but it's still the slope and the intercept of a straight line. But this is no longer a straight line, so b is no longer the slope because it's not a straight line. B is not the slope. But c, it turns out, is still the y-intercept. And I'll show you why in a second. The y-intercept is when x is 0. If you plug in x is 0 here, you get 0. If you plug in x is 0 here, you get 0. So you have 0 plus 0 plus c. And so the y value is just c. So the y-intercept is c. And then b, we'll talk about later. It has meaning, and it's used to find out information about the vertex or the root or things like that. But you can't, just the number b itself is not the answer to these questions, but its value is used in conjunction with other stuff to figure out the values of the vertexes and the roots if you have a parabola in this form. So we'll talk about this later when we start learning about the different forms and how to convert between them. Okay, so y equals ax squared plus bx plus c is called standard form. And if you know a, b, and c, you can write it in standard form, or if you see it in standard form, you can immediately identify the stretch factor and the y-intercept, and then b is not that useful right now. Okay, the third and final form is called factored form. So you might remember way back earlier in the year we did factoring quadratics. That's related to factored form. Okay, so we have y equals a times x minus r1 times x minus r2. Okay, so notice that in all three equations we had x and y, and then we had three different things. So in this one we have a, r1, and r2. In the previous one we had a, b, and c, and in the vertex form we had h, k, and a. So all of them have three numbers that you'll be filling in. A is again the stretch factor. So all three, that's the one thing they all have in common, is they all have an a, and it's always the stretch factor. But other than that, they have differences. So here r1 and r2, sorry, oh, that's a r1 and well, I can't write very well today. r1 and r2 are called roots. So this is a vocabulary word, roots, that you'll want to know. And that means that they're x-intercepts. Okay, so the roots of a parabola are the x-intercepts. And it's very important to recognize that because of this minus sign in the formula, the root itself is opposite sign of whatever number you see. So let me give you a quick example. If you have y equals 2 times x plus 3 times x minus 6, the roots, since it's x plus 3, it's supposed to be x minus r1. So negative 3 is actually what the root is. And since it's an x-intercept, you want to write it as negative 3 comma 0. That's one of the roots coming from here. And the other root, now here it's x minus 6, so x minus r2. Then r2 is just the 6, not the minus sign. So 6, and because it's an x-intercept, comma 0. So the roots are opposite sign of what you see in there. And the reason is because in order to be an x-intercept, when you plug in an x-intercept into a function, the y value or output should be 0. Well, look at this and say, what number can I plug in for x that will make this value 0? Well, you can't plug in 3 because 3 plus 3 is 6. You need to plug in negative 3. That way when you add them up, you get 0, and if you multiply by 0, you get 0 as the y value, which means that you have an x-intercept. So the number that you'd plug in to get an x-intercept is the opposite of whatever you have there right now. So that's why there's a minus sign in the formula, and that's why this is negative 3, even though the term is x plus 3. Okay, that's it for these three forms. We're going to go through them in class in a lot more detail, give lots of examples, and practice identifying them. But these are the definitions or kind of syntax for the three forms.